Welcome, and let your mind drift upward, beyond the valleys and plains of everyday life, to where the earth itself reaches toward the heavens. Tonight, we embark on a peaceful journey through the silent power of mountains, those ancient giants that have shaped not only our planet's surface, but the very essence of human civilization. As we explore together, allow yourself to breathe deeply, to settle into comfort, and to let these stories of stone and sky carry you through a landscape of quiet discovery. Mountains have always been more than mere geological features. They are the backbone of our world, the sleeping titans that define horizons and dreams alike. From the soaring peaks of the Himalayas to the volcanic spine of the Andes, from the graceful ridges of the Alps to the weathered wisdom of the Appalachians, each range tells a story written across millions of years, a narrative of pressure and patience, of fire and ice, of cultures born in their shadows and legends whispered in their winds. Let us begin our journey by understanding how these magnificent formations came to be. Deep beneath our feet, far below even the deepest valleys, the Earth moves in a slow, eternal dance. The planet's crust, that thin shell upon which all life exists, floats upon a sea of molten rock, divided into vast plates that drift with imperceptible slowness across the surface of our world. Where these plates meet, mountains are born. It is a process of unimaginable force meeting immovable resistance, played out over timescales that dwarf human comprehension. Consider the Himalayas, those mighty peaks that include Mount Everest, the roof of the world. Their story began some 50 million years ago when the Indian subcontinent, traveling northward on its tectonic plate like a colossal ship crossing an ancient ocean, collided with the Asian plate. This collision continues even now, at a pace of about 2 inches each year, roughly the speed at which our fingernails grow. Yet from this seemingly gentle motion has risen the most dramatic mountain range on Earth, a wall of rock and ice that influences weather patterns across half the globe. The formation of the Himalayas is a testament to the power of persistence. As the Indian plate pushed and continues to push against Asia, the ocean floor that once lay between them was forced upward, carrying with it the sediments of ancient seas. This is why climbers on Everest can find marine fossils near the summit, remnants of creatures that lived in warm, shallow waters hundreds of millions of years ago. These tiny shells and imprints, now frozen in limestone at altitudes where oxygen grows thin and temperatures plummet, remind us that even the mightiest mountains were once ocean floors, that what seems permanent and unchanging is merely a moment in Earth's long story. Moving gently westward in our thoughts, we encounter the Andes, stretching like a great spine along the western edge of South America. These mountains tell a different tale, one of fire rather than collision. The Andes are the product of subduction, where the oceanic Nazca Plate slides beneath the continental South American plate, descending into the Earth's mantle where it melts and returns to the planet's interior. This process creates a line of volcanoes, many still active, that have built the longest continental mountain range in the world, extending over 4,300 miles from the Caribbean to the southern tip of Chile. The volcanic nature of the Andes has blessed and cursed the civilizations that arose in their shadow. The soil, enriched by volcanic ash, supports agriculture at altitudes that would otherwise be barren. The ancient Inca understood this gift, developing sophisticated terracing systems that transformed steep mountainsides into productive farmland. These terraces, many still in use today, demonstrate how mountains shape not just landscapes, but human ingenuity itself. The Inca called the Andes Apu, meaning lord or deity, and indeed these mountains were not merely home, but were themselves divine, each peak a god watching over the valleys below. Now let us turn our attention to the Alps, those peaks that have defined European culture for millennia. The Alps formed through a complex series of events beginning around 100 million years ago, as Africa slowly pushed northward toward Europe, crumpling the Earth's crust like a tablecloth pushed from one end. But unlike the still-rising Himalayas or the volcanic Andes, the Alps tell a story of mountains shaped as much by erosion as by uplift. During the Ice Ages, massive glaciers carved deep valleys and sharp peaks, creating the dramatic landscape we know today. A geography of horn-shaped summits and U-shaped valleys that seems designed to inspire both awe and artistic expression. The influence of mountains on climate cannot be overstated, and nowhere is this more apparent than in the effect of the Himalayas on the Indian subcontinent. These peaks act as a colossal barrier, blocking cold winds from Central Asia and trapping the moisture-laden air of the Indian monsoon. Without the Himalayas, the Indian subcontinent would be a cold desert, similar to the Mongolian steppes. Instead, the mountains create one of the most fertile and densely populated regions on Earth. The monsoon, forced upward by the mountain wall, releases its moisture as rain, feeding the great rivers of Asia, the Ganges, the Brahmaputra, the Indus, and the Yangtze, rivers that sustain more than 1 billion people. As we contemplate these geological giants, we must also consider the human stories woven into their slopes. Mountains have always been boundaries, not just between nations, but between worlds. They separate climates, ecosystems, and cultures, creating pockets of isolation where unique traditions and languages flourish. In the valleys of the Himalayas, hundreds of distinct ethnic groups have developed their own customs, their own understanding of the world, shaped by the mountains that surround them. The Sherpa people of Nepal, perhaps the most famous of these mountain cultures, have evolved physical adaptations to high altitude, their bodies more efficient at using oxygen in the thin air, a gift from generations of ancestors who made their homes where others could barely breathe. The Alps, too, have created a patchwork of cultures. In their valleys, languages change from one village to the next, German giving way to French, French to Italian, Italian to Romansh, that ancient tongue still spoken in remote Swiss valleys. These linguistic islands exist because mountains make travel difficult, allowing cultures to develop in relative isolation, each valley a world unto itself. Yet paradoxically, mountains also connect. The passes through the Alps have been trade routes since before recorded history, paths along which not just goods but ideas, technologies, and diseases have traveled, shaping the development of European civilization. Let us explore now the spiritual significance of mountains, for these peaks have always been more than physical barriers or geological curiosities. In nearly every culture that has developed in sight of mountains, these elevations have been seen as sacred, as places where earth meets heaven, where mortals might communicate with the divine. Mount Kailash in Tibet, sacred to Hindus, Buddhists, Jains, and followers of Bon, has never been climbed, not because it is technically impossible, but because it would be sacrilege. Pilgrims circle its base, some prostrating themselves with every step, in journeys that can take weeks, believing that such devotion will cleanse them of sin and bring them closer to enlightenment. The ancient Greeks placed their gods on Mount Olympus, that cloud-wrapped peak where Zeus held court and from which the affairs of mortals were decided. The Japanese revere Mount Fuji, seeing in its perfect cone a symbol of beauty and spiritual power. Native American tribes of the Pacific Northwest speak of Mount Shasta as the home of the spirit of the above world. In the Andes, the Inca made sacrifices on the highest peaks, sometimes including children, who were believed to become ambassadors to the gods, their preserved bodies found centuries later by climbers, still dressed in their ceremonial clothes, faces peaceful in their eternal sleep. These spiritual associations are not arbitrary. Mountains inspire a particular emotional response in humans, a mixture of awe, fear, and attraction that psychologists call the sublime. Standing at the foot of a great peak, or looking out from a high place across a sea of clouds, we experience a shrinking of the ego, a recognition of our own insignificance that paradoxically makes us feel part of something infinitely larger. This feeling, this mountain-induced humility, has shaped philosophy, religion, and art throughout human history. Consider how mountains have influenced trade and economics throughout history. The Silk Road, that great artery of commerce that connected east and west for over a millennium, wound through some of the most challenging mountain terrain on Earth. Caravans crossing the Pamirs, the Tian Shan, and the Hindu Kush faced not just the physical challenges of altitude and weather, but also the human dangers of bandits and hostile tribes who controlled the passes. The goods that survived these journeys, silk and spices, jade and gold, commanded prices that reflected not just their rarity, but the difficulty of their transport. Mountains made trade dangerous and expensive, but also profitable for those brave enough to attempt it. In South America, The Inca built an empire in the mountains, connected by an intricate system of roads that traversed some of the most difficult terrain on Earth. These roads, many carved directly into cliffsides, included suspension bridges woven from grass that spanned gorges hundreds of feet deep. Chaska runners, a relay system of messengers, could carry information from one end of the empire to the other in days, running at altitudes where most people today would struggle to walk. This mountain-adapted civilization developed crops like potatoes and quinoa that could grow at high altitudes, foods that would eventually feed the world. The Alps became the crossroads of European trade, with passes like the Street Bernard and the Gotthard serving as crucial links between the Mediterranean and northern Europe. The communities that controlled these passes grew wealthy on tolls and services provided to traders. The Swiss Confederation itself emerged partly from the need to control and protect these vital mountain routes. Even today, the tunnels through the Alps, engineering marvels that bore through the heart of mountains, carry a significant portion of Europe's freight, the modern continuation of trade routes established millennia ago. Now let us delve deeper into the geological mysteries of mountain formation. The Himalayas, as we have discussed, rose from the collision of continents, but the details of this process are fascinating in their complexity. As India pushed into Asia, the crust didn't simply crumple upward. Instead, it broke into vast sheets that slid over one another like a deck of cards being pushed from one end. These thrust faults, as geologists call them, stacked layers of rock that had formed millions of years apart, creating a geological timeline that reads backwards, with older rocks sitting atop younger ones. The rocks of the Himalayas tell stories of multiple worlds. There are granites that form deep in the Earth's crust, heated to near melting by the pressure of collision. There are sedimentary rocks that preserve ripple marks from ancient beaches, the footprints of dinosaurs, the burrows of worms that lived hundreds of millions of years ago. There are metamorphic rocks, transformed by heat and pressure from one type to another, limestone becoming marble, shale becoming slate, their crystals aligned by the tremendous forces that shaped them. In the Andes, the geological story is one of recycling on a planetary scale. As the Nazca Plate descends beneath South America, it carries with it sediments from the ocean floor, water trapped in minerals, and the basalt of the oceanic crust itself. This material, heated by its descent into the Earth's interior, melts and rises, creating the volcanoes that built the Andes. But not all of this material erupts. Much of it cools underground, forming vast bodies of granite that are only exposed millions of years later as erosion strips away the overlying rock. These granites often contain valuable minerals, copper and gold, silver and tin, wealth that has both blessed and cursed the nations of the Andes. The Alps present yet another variation on the mountain building theme. Here, the collision between Africa and Europe was not direct but oblique, causing the crust to not just crumple but to shear sideways. This created the complex pattern of valleys and ridges that characterizes the Alps, a three-dimensional puzzle of rock types and structures that geologists are still working to fully understand. The Alps also show us how mountains die. Unlike the still-rising Himalayas, the Alps are in a mature phase of their existence, worn down by millions of years of erosion. Their peaks not as high as they once were, their valleys filled with the debris of their own destruction. Let us pause now to consider the ecosystems that mountains support, for these vertical worlds contain more biodiversity in a single slope than might be found across entire continents of flatland. As we ascend a mountain, we travel through life zones that mirror the journey from equator to poles. At the base of a tropical mountain, we might find rainforest, humid and species-rich. As we climb, the forest changes, becoming cooler, more temperate. Higher still, we encounter coniferous forests, then alpine meadows, and finally, near the peaks, a polar desert of rock and ice where only the hardiest life forms survive. This vertical zonation creates islands of habitat, evolutionary laboratories where species adapt to specific conditions of altitude and climate. Mountains are thus centers of endemism, home to species found nowhere else on Earth. The mountains of Madagascar, isolated from Africa for over 160 million years, host lemurs and chameleons, baobabs and orchids found nowhere else. The Andes are home to spectacled bears and vicuñas, giant groundsels and puya plants with flower spikes that can reach 30 feet tall. The Alps shelter ibex and marmots, edelweiss and alpine roses, each species precisely adapted to its mountain niche. The adaptation of life to mountains is a testament to the creativity of evolution. Plants develop cushion forms to resist wind, deep taproots to anchor in thin soil, and the ability to photosynthesize at low temperatures. Animals evolve larger lungs and hearts to cope with thin air, thicker fur to insulate against cold, and sure feet to navigate rocky terrain. The snow leopard of the Himalayas has evolved oversized paws that act as snowshoes, a long tail for balance on narrow ledges, and pale spotted fur that makes it nearly invisible against the mountain backdrop. These cats can leap 50 feet horizontally, hunting blue sheep on cliffs where a single misstep means death. Birds, too, show remarkable adaptations to mountain life. The bar-headed goose migrates over the Himalayas, flying at altitudes above 25,000 feet, where the oxygen level is a third of that at sea level. These birds have evolved more efficient hemoglobin, allowing them to extract oxygen from air that would render most animals unconscious. The Andean condor, with its 10-foot wingspan, uses mountain thermals to soar for hours without flapping, scanning vast territories for carrion. These magnificent birds can live for 70 years, their long lives allowing them to learn the complex wind patterns of their mountain homes. Mountains also play a crucial role in global water cycles. They are often called water towers, capturing moisture from passing air masses and storing it as snow and ice. The Himalayas and the Tibetan Plateau, sometimes called the Third Pole because they contain more ice than anywhere outside the Arctic and Antarctic, are the source of water for nearly half the world's population. The Ganges, Indus, Brahmaputra, Mekong, Yangtze, and Yellow rivers all begin in these mountains, their flow sustained by melting snow and glaciers. But this vital service is under threat. Mountain glaciers worldwide are retreating as global temperatures rise, a process that initially increases river flow as ice melts faster, but will eventually lead to water scarcity as the glaciers disappear. The Andes have lost over 30% of their glacier area in the past 50 years. Communities that have depended on glacial melt for centuries are finding their water sources unreliable. In the Himalayas, glacial lakes are forming behind unstable moraine dams, threatening catastrophic floods if these natural dams fail. Let us now journey through some of the lesser-known mountain ranges, each with its own character and stories. The Drakensberg Mountains of South Africa, the Dragon Mountains, rise like a wall along the eastern edge of the continent. These peaks are not formed by collision or subduction, but by the outpouring of vast amounts of basalt lava 180 million years ago. The result is an escarpment of layered cliffs, painted in shades of red and gold by iron oxides, a canvas on which the Sand People created thousands of rock paintings over thousands of years, depicting hunts and ceremonies, spirits, and dreams. The Urals, stretching from the Arctic Ocean to the Caspian Sea, are among the oldest mountains on Earth, formed over 250 million years ago when the continents of Europe and Asia collided. Worn down by eons of erosion, they are not particularly high, but they are immensely rich in minerals, their rocks containing everything from gold and platinum to emeralds and diamonds. The Urals have been mined for millennia, their wealth funding empires and wars, their depths yielding not just precious stones, but also the iron that armed armies and built cities. In North America, the Rockies tell a story of multiple mountain-building episodes, a complex history written in thrust faults and volcanic intrusions. These mountains, younger than the Appalachians to the east but older than the coastal ranges to the west, divide the continent's watersheds, sending some rivers east to the Atlantic and others west to the Pacific. A raindrop falling on certain peaks in Glacier National Park might flow either to Hudson Bay, the Pacific Ocean, or the Gulf of Mexico, depending on which side of the triple divide it lands. The Appalachians themselves, now gentle and worn, were once as tall as the Himalayas. Formed around 480 million years ago during the assembly of the supercontinent Pangaea, they have been eroded down to their roots, their once jagged peaks now rounded hills covered in deciduous forest. Yet these ancient mountains still influence the climate and culture of eastern North America, their valleys channeling weather systems, their coal deposits fueling the Industrial Revolution, their isolation preserving unique musical and linguistic traditions. Mountains have always challenged human ingenuity, forcing us to develop new technologies and techniques to traverse their heights. The invention of the ice axe and crampon opened up winter mountaineering. The development of fixed ropes and aluminum ladders made possible the ascent of vertical faces. Modern materials like Gore-Tex and synthetic insulation allow climbers to survive in conditions that would have killed earlier generations. Satellite phones and GPS devices have made mountain rescue more effective, though the mountains still claim lives every year, reminders that technology can mitigate but never eliminate the risks of high places. The construction of mountain roads and railways represents some of humanity's greatest engineering achievements. The Trans-Siberian Railway crosses the Urals, connecting Moscow to the Pacific. The Qinghai-Tibet Railway, completed in 2006, reaches altitudes over 16,000 feet, its carriages pressurized like aircraft cabins to protect passengers from altitude sickness. The mountain roads of the Andes, including the notorious Death Road in Bolivia, wind along precipices where a moment's inattention can be fatal. These routes, carved from solid rock or built on seemingly impossible grades, represent the human determination to connect, to trade, to explore, regardless of what nature places in our path. Let us consider now the role of mountains in warfare, for these natural fortifications have shaped the outcomes of countless conflicts. Hannibal's crossing of the Alps with his elephants in 218 BCE remains one of history's most audacious military maneuvers, a feat that cost him half his army but brought him to the gates of Rome. The mountain passes of Afghanistan have been the graveyard of empires, from Alexander the Great to the British Empire to the Soviet Union, the terrain favoring defenders who know every cave and trail. During World War I, Italian and Austrian troops fought for 3 years in the Alps, sometimes at altitudes above 10,000 feet, where more soldiers died from avalanches and cold than from enemy fire. They carved entire cities into the ice, with barracks, hospitals, and supply depots connected by tunnels through glaciers. The remnants of this White War, as it was called, still emerge from melting ice, preserved artifacts and bodies appearing a century after they were lost, ghosts of a conflict fought in conditions that tested the absolute limits of human endurance. Mountains have also served as refuges, places where persecuted peoples could find safety in isolation. The Waldensians fled to the Alps to escape religious persecution. The Druze took refuge in the mountains of Lebanon. The Kurdish people have maintained their culture in the mountains that span Turkey, Iraq, Iran, and Syria, the terrain providing protection from the various empires that have tried to subjugate them. In World War II, resistance movements from France to Yugoslavia used mountain hideouts to organize against occupation, the difficult terrain neutralizing the advantages of mechanized armies. The cultural impact of mountains extends far into the arts. Mountains appear in the earliest literature, from Gilgamesh's journey to the Cedar Mountain to Moses receiving the commandments on Mount Sinai. The Romantic movement of the 18th and 19th centuries transformed mountains from obstacles to be avoided into destinations to be sought, places where one could experience the sublime and commune with nature. Wordsworth wandered the Lake District's fells, finding in them spiritual renewal. Caspar David Friedrich painted figures contemplating mountain vistas, capturing the sense of awe and isolation that mountains inspire. In Asian art, mountains have always held a special place. Chinese landscape paintings, with their misty peaks and tiny human figures, express the Taoist concept of humanity's place in nature. Japanese ukiyo-e prints, especially Hokusai's 36 views of Mount Fuji, capture the mountain in different seasons and weather, showing how a single peak can have infinite moods and meanings. These artistic traditions influenced Western art, introducing new ways of seeing and representing the natural world. Music, too, has been shaped by mountains. The alphorn, that long wooden instrument whose haunting call echoes across valleys, developed as a way for shepherds to communicate across the vast spaces of mountain pastures. Yodeling, that distinctive form of singing that rapidly alternates between chest and head voice, evolved in the Alps as another form of long-distance communication, its techniques later influencing country music in America. The throat singing of Mongolia and Tuva mimics the sounds of wind through mountain passes, creating multiple tones simultaneously in harmonies that seem impossible for a single human voice to produce. Mountains have given us some of our most powerful metaphors. We speak of reaching peaks of achievement, of having mountain-high ambitions, of making mountains out of molehills. We describe challenges as uphill battles and easy tasks as downhill runs. The mountain as metaphor appears in spiritual teachings worldwide, from the Sermon on the Mount to the Buddhist concept of climbing the mountain of enlightenment. These metaphors resonate because mountains embody fundamental human experiences of struggle, achievement, perspective, and transformation. Let us explore now the fascinating world of mountain weather, for these elevated lands create their own climates, their own storms, their own atmospheric phenomena. Mountains force air masses upward, cooling them and causing precipitation on windward slopes while creating rain shadows on leeward sides. This orographic effect can create dramatic differences in climate over very short distances. The western slopes of the Cascade Range in North America receive over 100 inches of rain annually, while the eastern slopes, just miles away, are desert. Mountains generate their own winds. In the morning, as the sun heats mountain slopes, air rises, creating valley breezes that flow upslope. In the evening, as the slopes cool, the process reverses, creating mountain breezes that flow down into valleys. These daily cycles of wind have been used for centuries by glider pilots who ride the thermals, and by birds of prey who patrol ridgelines where updrafts bring them both lift and food. The lenticular clouds that form over mountains, those lens-shaped formations that look like flying saucers, are created when stable air flows over peaks, creating standing waves in the atmosphere. These clouds remain stationary even as wind flows through them, condensing on the upwind side and evaporating on the downwind side. They are signs of powerful atmospheric waves that can extend far downwind of mountains, creating turbulence that can affect aircraft hundreds of miles away. Lightning in mountains presents unique dangers. Peaks act as lightning rods, attracting strikes that can travel through wet rock, endangering climbers far from the strike point. The thin air at altitude provides less insulation, making lightning more likely to strike. Mountaineers learn to recognize the signs of an approaching strike: hair standing on end, metal objects humming, the smell of ozone. They learn to descend quickly when afternoon thunderstorms build, for mountains have a way of generating sudden, violent weather from seemingly clear skies. The aurora borealis and aurora australis, those dancing lights in polar skies, are often best viewed from mountains above the haze and light pollution of lower elevations. These displays, caused by solar particles interacting with Earth's magnetic field, seem especially magical when viewed from a mountain summit, the lights appearing to dance among the peaks themselves. Indigenous peoples of the North have long told stories of these lights, seeing in them the spirits of ancestors or animals, the play of celestial beings, the bridge between earth and sky that mountains themselves represent. Now let us turn our attention to the extraordinary geological phenomena found in mountains. Consider the formation of caves, those hidden worlds within mountains that can extend for hundreds of miles. Limestone mountains are particularly prone to cave formation, as slightly acidic rainwater dissolves the rock over millions of years, creating vast underground chambers adorned with stalactites and stalagmites, flowstones, and cave pearls. The Mammoth Cave system in Kentucky's Modest Mountains extends for over 400 miles that have been mapped, with new passages still being discovered. Some mountain caves preserve records of past climates in their formations. The growth rings in stalagmites, like tree rings, record changes in temperature and rainfall over hundreds of thousands of years. These caves also preserve archaeological treasures. The caves of the Zagros Mountains yielded the first evidence of Neanderthal burial practices. The high-altitude caves of the Himalayas have preserved manuscripts and artifacts for centuries in their cold, dry environments, including ancient Buddhist texts that have revolutionized our understanding of early Buddhism. Mountains also host unique geological formations like columnar basalt, those hexagonal pillars of rock that look like they were carved by giants. These form when thick lava flows cool slowly and evenly, contracting and cracking in regular patterns. The Giant's Causeway in Northern Ireland, though not strictly mountainous, shows this phenomenon, but it occurs in mountain ranges worldwide where volcanic activity has occurred. These geometric formations have inspired legends everywhere they occur. They're two perfect patterns, seeming evidence of supernatural construction. The mineral wealth of mountains extends beyond precious metals and gems. Mountains are sources of building materials that have shaped architecture worldwide. The marble quarries of Carrara in the Apuan Alps have provided stone for sculptures and buildings since Roman times. Michelangelo himself traveled to these quarries to select blocks for his sculptures, seeing in the veins and colors of the stone the figures waiting to be released. The granite of the Sierra Nevada, the limestone of the Dolomites, the slate of Wales, all have been shaped by human hands into expressions of beauty and utility. Hot springs and geysers, common in volcanic mountains, have been recognized for their therapeutic properties since ancient times. The Romans built elaborate bath complexes at mountain hot springs throughout their empire. In Japan, the tradition of onsen, bathing in natural hot springs, is deeply embedded in the culture, with many of the most prized springs located in mountainous areas. These thermal features remind us that mountains are not static but dynamic, that beneath their solid appearance lies heat and movement, the same forces that created them still active, still shaping the land. Let us consider the future of mountains in our rapidly changing world. Climate change is altering mountain ecosystems faster than species can adapt or migrate. The tree line is advancing upslope, shrinking alpine meadows and the specialized communities they support. Ski resorts at lower elevations are struggling with shorter seasons and less reliable snow, some turning to artificial snow that requires enormous amounts of water and energy to produce. The cultural traditions tied to mountain winters, from winter festivals to ice climbing, face uncertain futures. Yet mountains also offer solutions to some of our environmental challenges. The steep slopes and strong winds of mountains make them ideal sites for renewable energy. Wind farms on mountain ridges can generate electricity with minimal land use. Pumped storage hydroelectricity, where water is pumped uphill when energy is abundant and released through turbines when needed, uses mountain topography to store energy. The consistent temperature of mountain caves and mines can be used for energy-efficient cooling of data centers, the digital infrastructure of our connected world finding refuge in ancient rock. Mountains are also becoming refugia for species threatened by climate change. As temperatures rise, species can migrate upslope to find suitable conditions, though this is a temporary solution that ends when there is nowhere higher to go. Conservation efforts increasingly focus on maintaining corridors that allow species to move between mountain ranges, recognizing that static protected areas may not be enough in a changing world. The mountains themselves become arcs, preserving biodiversity for an uncertain future. The spiritual significance of mountains continues to evolve in our modern age. As urbanization increases, mountains become ever more important as places of pilgrimage, not necessarily religious, but spiritual in a broader sense. People seek in mountains an antidote to the complexity and pace of modern life, a place where priorities clarify and perspectives shift. The growth of hiking, climbing, and mountain tourism reflects this need, though it brings its own challenges as popular peaks become crowded and wilderness loses its wildness. Let us journey now through some of the world's most remarkable individual peaks, each with its own character and story. K2, the second highest mountain on Earth, stands on the border between Pakistan and China, a pyramid of ice and rock that mountaineers call the Savage Mountain. Unlike Everest, which can be climbed by relative novices with sufficient support, K2 demands technical expertise at every step. Its weather is notoriously unpredictable, its avalanches frequent, its slopes unforgiving. For every 4 people who have reached its summit, 1 has died trying, a sobering statistic that speaks to the mountain's uncompromising nature. Denali, formerly Mount McKinley, rises from near sea level to over 20,000 feet, making it one of the most prominent peaks on Earth in terms of vertical relief. Located in Alaska, it creates its own weather, so severe that temperatures on its upper slopes rival those of Antarctica. The mountain tests climbers not with altitude, though that is challenging enough, but with cold and storms that can pin expeditions in their tents for weeks. The indigenous Athabascan people call it Denali, the Great One, a name that speaks to its dominance of the landscape and imagination. The Matterhorn, that perfect pyramid of rock that straddles the border between Switzerland and Italy, has become perhaps the most photographed mountain in the world, its distinctive shape gracing everything from chocolate boxes to corporate logos. Yet this beautiful peak is also deadly, having claimed over 500 lives since its first ascent in 1865. Its seemingly simple ridges hide complex route-finding challenges, and its exposed position makes it a magnet for lightning and sudden storms. The Matterhorn reminds us that beauty and danger often walk hand in hand in the mountains. Mount Kilimanjaro rises from the plains of Tanzania, the highest freestanding mountain in the world. Its summit snows, made famous by Hemingway, are disappearing, likely to be gone entirely within decades. This mountain is actually 3 volcanic cones fused together, and while it is currently dormant, gas still escapes from fumaroles in the summit crater, reminders that Kilimanjaro is merely sleeping, not dead. The mountain slopes host an extraordinary range of ecosystems, from tropical rainforest at its base through heath and moorland to alpine desert, and finally, to the Arctic conditions of its summit. Aconcagua, the highest peak in both the western and southern hemispheres, stands in the Andes on the border between Argentina and Chile. Despite its great height of nearly 23,000 feet, it is considered technically easy to climb, requiring no special equipment beyond that needed for extreme altitude and cold. Yet this accessibility is deceptive. The mountain's altitude, combined with the fierce winds that can exceed 100 miles per hour, creates conditions that kill several climbers each year. The mountain's name may derive from the Quechua words for sentinel of stone, an apt description for this giant that guards the approaches to the Pacific. Mount Elbrus in the Caucasus, Europe's highest peak, stands at the intersection of continents and cultures. This dormant volcano, with its twin summits covered in glaciers, has been a landmark since ancient times. The Greeks knew it as Strobilus, and in their mythology, it was here that Zeus chained Prometheus as punishment for giving fire to humanity. During World War II, German mountain troops planted a Nazi flag on its summit, which Soviet climbers later removed in a daring wartime ascent. Today, Elbrus is climbed by thousands each year, though its weather and altitude still claim lives, the mountain indifferent to the human dramas played out on its slopes. The volcanic peaks of the Pacific Ring of Fire present their own unique challenges and opportunities. Mount Fuji, Japan's highest peak, is climbed by over 200,000 people each year during the short summer climbing season. This seemingly gentle giant is actually an active volcano that last erupted in 1707, its perfect cone shape the result of layers of lava and ash from countless eruptions. The mountain is sacred in Shintoism, and climbing it is as much a spiritual journey as a physical one. Pilgrims ascending through the night to witness sunrise from the summit, a moment of enlightenment as the first rays illuminate the sea of clouds below. Mount Rainier, looming over Seattle, is considered one of the most dangerous volcanoes in the world, not because of the likelihood of eruption, but because of the consequences if it does erupt. The mountain's glaciers, the most extensive in the contiguous United States, would melt catastrophically in an eruption, creating lahars, volcanic mud flows that could reach Puget Sound in less than an hour. Yet this dangerous mountain is also a training ground for mountaineers, its glaciated slopes and unpredictable weather providing preparation for expeditions to the great ranges of the world. In New Zealand, Aoraki Mount Cook rises from near sea level to over 12,000 feet, its Maori name meaning cloud piercer. This mountain has shaped New Zealand's mountaineering heritage, serving as training ground for Edmund Hillary before his historic ascent of Everest. The Southern Alps, of which Aoraki is the crown jewel, are among the fastest rising mountains in the world, pushing up at rates of up to 10 millimeters per year, though erosion wears them down almost as quickly as they rise. A dramatic example of the constant battle between uplift and erosion that shapes all mountains. The mountains of Antarctica, though less famous than those of other continents, include some of the most remote and challenging peaks on Earth. The Vinson Massif, the continent's highest peak, rises from the ice sheet in the Sentinel Range. Climbing here means dealing not just with altitude and cold, but with the logistical challenges of reaching the most isolated continent on Earth. The mountains of Antarctica preserve records of Earth's climate history in their ice, cores drilled from glaciers containing bubbles of atmosphere from hundreds of thousands of years ago, time capsules that tell us about past climates and help predict future ones. Let us now explore the intricate relationships between mountains and rivers, for every major river system on Earth begins in mountains. The Amazon, the world's largest river by volume, has its source in the Peruvian Andes, a small spring on the slopes of Nevado Mizmi that grows to a river so vast that ocean-going ships can navigate it thousands of miles inland. The journey of water from mountain peak to ocean is one of constant transformation, from snow to meltwater, from rushing stream to meandering river, carrying with it sediments that build deltas and nourish floodplains. The Nile, the world's longest river, has its most distant source in the mountains of Rwanda and Burundi, though its flow depends heavily on the seasonal rains in the Ethiopian highlands. The Blue Nile, rising in Lake Tana in Ethiopia, provides most of the water and all of the fertile sediment that has made Egyptian civilization possible. Without the mountains of East Africa, the Nile Valley would be just another stripe of the Sahara Desert. The ancient Egyptians, though they never saw these distant peaks, owed their entire civilization to mountains they didn't know existed. The relationship between mountains and rivers is not always benign. Mountain rivers are prone to catastrophic floods, especially when rain combines with snowmelt or when natural dams formed by landslides or glaciers suddenly fail. The Ganges, usually a life-giving force, can become a destroyer when monsoon rains in the Himalayas exceed the river's capacity. The history of human settlement in mountain valleys is punctuated by flood disasters. Communities rebuilt again and again in the same locations because the fertile soil and access to water outweigh the risks. Rivers carve mountains even as mountains give them birth. The Grand Canyon, though not in a particularly high mountain range, shows the power of water to cut through rock, the Colorado River having carved a mile-deep gorge through layers of stone that record 2 billion years of Earth's history. In the Himalayas, some rivers are older than the mountains themselves, having maintained their courses even as the land rose beneath them, cutting gorges that are among the deepest on Earth. The Kali Gandaki in Nepal flows between the peaks of Dhaulagiri and Annapurna, creating a valley that is, by some measures, the world's deepest gorge. Mountain lakes add another dimension to the hydrology of high places. Some, like Lake Titicaca in the Andes, are remnants of ancient seas, trapped and lifted by the rising mountains. Others are created by glacial erosion, cirques filled with meltwater that reflect the sky like mirrors set in stone. These lakes often have no outlet except evaporation, concentrating minerals over time. The Dead Sea, lying in the Jordan Rift Valley, is so salty that nothing can sink in its waters, its minerals precipitating out to form bizarre salt sculptures along its shores. The glacial lakes of mountains are particularly beautiful and particularly vulnerable. As glaciers retreat, they often leave behind moraines, natural dams of rock and debris that hold back meltwater. These lakes can be stunning, their waters colored turquoise by glacial flour, fine particles of rock ground by the glacier's movement. But they are also dangerous. If the moraine dam fails, the resulting flood can devastate valleys downstream. In the Himalayas, the threat of glacial lake outburst floods grows as climate change accelerates glacial melting. Communities that have existed for centuries suddenly vulnerable to catastrophes their ancestors never faced. Underground rivers and mountains create some of the most spectacular cave systems on Earth. In the karst mountains of Vietnam, the Sun Dung Cave contains passages large enough to fly a Boeing 747 through, with underground rivers, forests growing beneath skylights where the ceiling has collapsed, and formations that dwarf human visitors. These underground waterways dissolve and sculpt the rock from within, creating hidden worlds that may remain undiscovered for millions of years, only revealed when erosion or exploration opens an entrance to the surface world. The study of mountains, orology, has revealed much about how our planet works. Mountains are archives of Earth's history, their rocks and fossils telling stories of vanished oceans, extinct creatures, and climates utterly unlike our own. The principle of superposition, that in undisturbed sequences older rocks lie beneath younger ones, was first understood by studying mountain strata. The discovery of thrust faults in mountains helped geologists understand that the Earth's crust could move horizontally as well as vertically. The theory of plate tectonics itself grew from observations of mountains, their distribution and characteristics providing clues to the underlying processes that shape our planet. Mountains have also taught us about deep time, that vast expanse of Earth's history that dwarfs human experience. When James Hutton looked at the rocks of Scotland's mountains in the 18th century, he saw evidence of cycles of erosion and deposition that must have taken unimaginable spans of time, leading him to declare that he could see no vestige of a beginning, no prospect of an end. This recognition of deep time was revolutionary, overturning religious and philosophical assumptions about Earth's age and opening the door to modern geology and evolutionary biology. The fossils found in mountains have been particularly important in understanding the history of life. The Burgess Shale in the Canadian Rockies preserves soft-bodied creatures from the Cambrian explosion, that moment 540 million years ago when complex life forms suddenly diversified. These fossils, found at 8,000 feet elevation, show creatures so strange that paleontologists initially couldn't place them in any known group. Animals with 5 eyes, with grasping arms extending from their heads, with bodies that seem designed by committee. They remind us that the story of life is not one of inevitable progress, but of experimentation, extinction, and occasional spectacular success. Mountains continue to surprise us with new discoveries. Recently, scientists have found ecosystems in the deepest parts of mountain caves that derive their energy not from sunlight, but from chemical reactions, communities of bacteria that eat rock and create the basis for food chains that include blind fish and transparent insects. In the Andes, researchers have discovered that some of the world's highest-dwelling mammals, including mice that live above 20,000 feet, have evolved unique adaptations to extreme altitude, their hemoglobin structured differently from their lowland relatives, their metabolism adjusted to extract maximum energy from scarce oxygen. The permafrost of high mountains preserves organic material that would quickly decay at lower elevations. The famous Iceman, Otzi, discovered in the Alps, had been preserved for over 5,000 years, his body, clothes, and equipment providing an unprecedented window into Copper Age life. His stomach contents revealed his last meal, the pollen in his gut indicated the season of his death, and the isotopes in his teeth told researchers where he had lived at different times in his life. Mountains, in preserving him, gave us a time machine, a direct connection to an individual who lived before the pyramids were built. Climate science has been revolutionized by studies conducted in mountains. Ice cores from mountain glaciers contain detailed records of past atmospheres, the bubbles in the ice preserving samples of ancient air. The ratio of different oxygen isotopes in the ice reveals past temperatures, while dust layers indicate volcanic eruptions or dry periods. These records show that Earth's climate has varied dramatically over time, with periods far warmer and far colder than today, but they also show that the current rate of warming is unprecedented in the geological record, a change happening in decades rather than millennia. Mountains serve as early warning systems for environmental change. Because ecosystems are compressed into narrow elevation bands on mountains, small changes in temperature can cause dramatic shifts in species distribution. The upward march of tree lines, the disappearance of alpine flowers, the retreat of glaciers, all provide visible evidence of a warming world. Mountains are like canaries in the coal mine of climate change. They're sensitive ecosystems responding quickly to changes that might take longer to manifest in more stable environments. The human communities of mountains are also adapting to change, though not always by choice. Traditional pastoral systems, where herders move their animals seasonally between elevations, are being disrupted by changing weather patterns and modernization. Young people leave mountain villages for education and employment in cities, leading to abandonment of terraces and traditional farming practices that maintain mountain landscapes for centuries. Yet there are also movements to preserve and revive mountain cultures, recognition that traditional knowledge about living sustainably in difficult environments may be more valuable than ever in an uncertain future. Tourism presents both opportunities and challenges for mountain communities. It can provide income and incentive to preserve traditional cultures and environments, but it can also overwhelm fragile ecosystems and commodify sacred spaces. Mount Everest has become a symbol of this contradiction, with hundreds of climbers attempting the summit each year. leaving behind tons of waste and occasionally their bodies, preserved in the mountain's eternal freeze. The mountain that Tibetans call Komolungma, Mother Goddess of the World, has become a trophy, its summit a destination to be conquered rather than a sacred space to be revered. Yet there are examples of sustainable mountain tourism that benefits both visitors and local communities. In Bhutan, tourism is limited and regulated, with visitors required to pay daily fees that fund conservation and development. In the European Alps, networks of mountain huts allow hikers to traverse ranges while minimizing environmental impact, the huts supplied by helicopter or cable car rather than roads. These models show that it is possible to share the beauty and wonder of mountains while preserving them for future generations. The governance of mountains presents unique challenges. Many ranges form international borders, requiring cooperation between nations for conservation and management. The Alps are shared by 8 countries, each with different laws and priorities, yet they have managed to create transboundary parks and coordinate conservation efforts. The Himalayas, shared by even more nations with complex political relationships, present greater challenges, with disputes over borders sometimes preventing coordinated conservation efforts. Indigenous peoples often have different concepts of mountain ownership and management than nation-states. For many indigenous groups, mountains are not property to be owned, but relatives to be respected. The Maori of New Zealand successfully negotiated for Aoraki Mount Cook to be recognized as an ancestor, with legal personhood and rights. The Inca concept of Alis, communities that include not just people but the mountains, rivers, and fields of their territory, offers a model of integrated landscape management that Western conservation is beginning to appreciate and adopt. As we contemplate the future of mountains, we must consider not just their physical preservation, but their cultural and spiritual significance. Mountains have always been more than geological features. They are repositories of meaning, anchors of identity, sources of inspiration. In preserving mountains, we preserve not just ecosystems and water sources, but the possibility of transcendence, the opportunity for challenge and growth, the reminder that there are forces and timescales greater than human ambition. The silence of mountains, that profound quiet that gives them their power, is increasingly rare in our noisy world. Even remote peaks now echo with the sound of helicopters, the beeping of satellite phones, the chatter of guided groups. Yet there remain places where the only sounds are wind and water, rockfall and birdsong, where the silence is so complete that you can hear your own heartbeat, the blood rushing in your ears. These moments of mountain silence are precious beyond measure, opportunities to hear not just the absence of human noise, but the presence of something deeper, older, more enduring. Let us continue our journey by exploring the profound influence mountains have had on human spirituality and mythology across cultures. In Hindu and Buddhist cosmology, Mount Meru stands at the center of the universe, its peaks reaching into heavenly realms while its roots extend deep into the underworld. Though Meru is mythological, its concept has influenced the architecture of temples and stupas throughout Asia, their ascending tiers representing the spiritual journey toward enlightenment. The physical mountains of the Himalayas become earthly manifestations of this cosmic mountain, each peak a step on the ladder between earth and heaven. The ancient Greeks saw mountains as the dwelling places of gods and titans. Before Zeus and the Olympians, the Titans ruled from mountain strongholds, and the war between these generations of gods was fought among the peaks. Mount Parnassus was sacred to Apollo and the Muses, its slopes home to the oracle at Delphi, where prophecies emerged from cracks in the mountain rock. The Greeks understood that mountains were places where the veil between worlds grew thin, where mortals might glimpse the divine or receive messages from beyond ordinary reality. In the Abrahamic traditions, mountains are sites of revelation and covenant. Moses received the 10 Commandments on Mount Sinai, the mountain itself trembling and smoking with divine presence. Abraham's willingness to sacrifice Isaac was tested on Mount Moriah. Jesus delivered his most famous sermon on a mountainside, was transfigured on a high mountain, and was crucified on a hill outside Jerusalem. Muhammad received his first revelation in a cave on Mount Hira. These mountain encounters shaped 3 of the world's major religions, establishing a pattern of seeking the divine in high places that continues to this day. Native American traditions speak of mountains as living beings with consciousness and power. The Lakota regard the Black Hills as the heart of everything that is, the center of their universe. The Navajo recognize four sacred mountains that bound their traditional homeland, each associated with a color, a time of day, and specific spiritual qualities. These mountains are not simply landmarks but active participants in the spiritual life of the people, beings to be addressed in prayer, consulted for wisdom, and treated with respect. The Aboriginal Australians see mountains as created by ancestral beings during the Dreamtime, that primordial period when the landscape was sung into existence. Uluru, though technically an Inselberg rather than a mountain, rises from the central Australian desert as a massive presence that embodies multiple creation stories. The rocks, caves, and formations each tell different tales, some so sacred that they cannot be photographed or climbed, knowledge that is held separately by different groups according to their ancestral connections. In the Andes, the concept of APU, the mountain spirits, remains central to indigenous spirituality. Each significant peak has its own personality, its own preferences for offerings, its own sphere of influence. The Apus control weather, water, and the fertility of crops and animals. They can be benevolent or vengeful, depending on how they are treated. Even today, travelers in the high Andes might see small piles of stones, apicatas, where offerings of coca leaves, alcohol, or cigarettes are left to ensure safe passage through the domain of the mountain spirits. The Japanese relationship with mountains is particularly complex, combining Shinto animism with Buddhist philosophy. Mountains are seen as Shintai, physical objects that house kami, the spirits or essences of nature. Certain mountains are so sacred that women were historically forbidden to climb them, a prohibition that lasted until the 19th century on Mount Fuji and continues on some peaks today. The practice of shujendo, mountain asceticism, involves rigorous training in mountain environments to achieve spiritual power. Its practitioners, called yamabushi, undertaking pilgrimages that test both physical and spiritual endurance. Mountains feature prominently in creation myths worldwide. In Norse mythology, the world was created from the body of the giant Ymir, his bones becoming mountains. The Chinese goddess Nuwa used mountains as pillars to support the sky after it was damaged in a cosmic battle. The ancient Egyptians believed that mountains at the edge of the world supported the sky, while the sun traveled through mountain passes in its journey through the underworld each night. These stories reflect a universal recognition of mountains as fundamental structures of reality, the pillars and boundaries of the world we inhabit. The symbolism of mountains extends into literature and philosophy. Dante's Purgatorio depicts the mountain of Purgatory as a place of spiritual refinement, its 7 terraces corresponding to the 7 deadly sins, souls ascending as they purify themselves. Thomas Mann's The Magic Mountain uses a tuberculosis sanatorium in the Swiss Alps as a microcosm of pre-World War I European society, the mountain's isolation allowing for philosophical contemplation removed from the pressures of normal life. Hermann Hesse's Journey to the East and Siddhartha use mountain crossings as metaphors for spiritual transformation. The Romantic movement of the 18th and 19th centuries fundamentally changed Western attitudes toward mountains. Previously seen as wastelands, obstacles, or at best sources of resources, mountains became destinations for aesthetic and spiritual experience. This shift is visible in the paintings of the period, where mountains transform from background elements to main subjects, their sublime terror and beauty capturing the romantic fascination with powerful emotions and the natural world. This cultural shift laid the groundwork for modern environmentalism and the conservation movement. The development of mountaineering as a sport in the 19th century was as much about spiritual and personal challenge as physical achievement. The golden age of alpinism, when most of the major alpine peaks were first climbed, coincided with industrialization and urbanization, suggesting that mountains offered something essential that modern life lacked. The writings of early mountaineers are filled with mystical experiences, moments of transcendence, and philosophical reflections prompted by their encounters with vertical worlds. The idea of mountains as places of spiritual retreat has ancient roots but finds new expression in the modern world. Meditation centers and yoga retreats are often located in mountain settings, using the natural peace and beauty of high places to facilitate inner work. The thin air of altitude has been shown to produce mild hypoxia that can trigger altered states of consciousness, possibly explaining some of the mystical experiences reported at high elevations. Whether through physical, psychological, or spiritual mechanisms, mountains seem to facilitate experiences of expanded consciousness and connection to something greater than ordinary selfhood. Let us now examine the remarkable biodiversity of mountain regions and the evolutionary pressures that have created unique adaptations. Mountains are evolutionary laboratories where isolation, extreme conditions, and diverse habitats drive speciation at accelerated rates. The concept of island biogeography, developed to explain species distribution on oceanic islands, applies equally to mountains, which function as sky islands of habitat surrounded by inhospitable lowlands. The vertical zonation of mountains creates multiple ecosystems stacked one above another, each with its own community of specially adapted organisms. In tropical mountains, this zonation is particularly dramatic. On Mount Kenya, for example, one can travel from elephant-inhabited savanna through bamboo forests, giant heather zones, and Afro-alpine moorlands to reach glaciers and bare rock, all within a horizontal distance of less than 50 miles. Each zone has endemic species found nowhere else, products of millions of years of isolation and adaptation. The plants of high mountains show remarkable convergent evolution, with unrelated species on different continents developing similar adaptations to similar conditions. Cushion plants, which grow in dense, low mounds to resist wind and conserve heat, have evolved independently in the Andes, Alps, Himalayas, and New Zealand mountains. These plants create their own microclimates. The temperature inside a cushion sometimes 20 degrees warmer than the surrounding air. They grow so slowly that a cushion the size of a dinner plate might be centuries old, making them among the oldest living things on Earth. Alpine flowers have evolved strategies to attract pollinators in environments where insects are scarce and weather unpredictable. Many produce disproportionately large, brightly colored flowers to attract attention from a distance. Some track the sun throughout the day, their petals acting as parabolic reflectors that focus warmth on their reproductive organs, creating warm spots where insects can shelter. Others have given up on insect pollination entirely, reproducing clonally through runners or bulbils, trading genetic diversity for reproductive certainty. The animals of mountains show equally remarkable adaptations. The vicuña of the Andes has blood with an unusually high affinity for oxygen, allowing it to thrive at altitudes where other mammals would suffocate. Its wool, among the finest natural fibers in the world, provides insulation against the fierce temperature swings of high-altitude deserts. The Inca reserved vicuña wool for royalty, and even today, with controlled harvesting, it remains one of the world's most expensive textiles. Mountain goats and their relatives have evolved extraordinary climbing abilities. Their hooves are split and slightly concave, with hard edges and soft centers that provide grip on the smallest ledges. They can climb near vertical faces that would challenge technical climbers, their movements combining strength, balance, and an apparently innate understanding of rock mechanics. Watching an ibex traverse a cliff face, leaping gaps that seem impossible, choosing holds invisible from a distance, one witnesses millions of years of evolution perfected into living artistry. The birds of mountains include some of the most impressive flyers in the animal kingdom. The bearded vulture, or lammergeier, has evolved a unique feeding strategy, dropping bones from height to crack them open and access the marrow within. With a wingspan approaching 10 feet, these birds soar on mountain thermals, covering vast territories in search of carcasses. Their gastric acid is so strong it can digest bone, allowing them to exploit a food source unavailable to other scavengers. High-altitude lakes host unique communities of organisms adapted to intense ultraviolet radiation, low temperatures, and limited nutrients. Some of these lakes are colored pink or red by algae that produce carotenoid pigments as sunscreen. The flamingos that feed on these algae in Andean lakes derive their pink coloration from these same pigments, a visible link in the food chain. These birds nest at altitudes above 14,000 feet, their chicks hatching in an environment where nighttime temperatures drop well below freezing. Cave-dwelling organisms in mountains represent some of the most extreme adaptations to challenging environments. Many have lost their eyes and pigmentation, unnecessary in eternal darkness. They've evolved enhanced other senses, with some cave fish able to detect the slightest water movements through lateral line organs, essentially seeing with their entire body. Some cave insects have elongated appendages that help them navigate in darkness, their antennae and legs serving as sensitive probes in a world without light. The soil ecosystems of mountains are particularly fascinating, hosting communities of organisms adapted to extreme conditions. Glacier mice, those balls of moss that mysteriously move across glaciers, create mobile ecosystems, each ball hosting hundreds of species of microscopic animals. The cryoconite holes that form on glacier surfaces, cylindrical melt holes filled with sediment and organic matter, support communities of bacteria, algae, and microscopic animals that remain active at temperatures near freezing. The study of mountain biodiversity has revealed fundamental principles of ecology and evolution. The species-area relationship, the observation that larger areas support more species, was first quantified in mountains. The concept of keystone species, organisms whose presence or absence dramatically affects ecosystem structure, emerged from studies of mountain predators and their prey. The understanding of how climate change affects species distribution comes largely from observations of elevational shifts in mountain organisms. Mountains also preserve evolutionary relics, species that once had wider distributions but now survive only in mountain refugia. The Woolemi pine, discovered in a remote Australian gorge in 1994, was known only from fossils and thought extinct for millions of years. The Dawn redwood, found in a remote valley in China in 1944, was similarly thought to be extinct. These living fossils survived in mountain valleys that provided stable conditions while climate change eliminated them elsewhere. The coevolution of plants and their pollinators reaches extraordinary levels of specialization in mountains. Some alpine plants have evolved flowers that exactly match the tongue length of specific butterfly or moth species. If the pollinator goes extinct, so does the plant, and vice versa. These tight relationships make mountain ecosystems particularly vulnerable to disruption, with the loss of a single species potentially triggering cascading extinctions. Parasitism and mutualism in mountain ecosystems show unique patterns. The cushion plants that characterize many alpine environments often function as nurse plants, sheltering other species that couldn't survive the harsh conditions alone. What appears to be a single cushion might host dozens of other plant species growing within its protection. This facilitation is crucial for ecosystem development in harsh environments, with pioneer species creating conditions that allow others to establish. Mountains serve as corridors for species movement, particularly during climate change. During ice ages, species moved downslope and toward the equator. During warm periods, they moved upslope and toward the poles. Mountain chains that run north-south, like the Rockies and Andes, provide continuous corridors for these migrations. Chains that run east-west, like the Himalayas and Alps, can act as barriers, trapping species that cannot cross the high passes. The genetic diversity within mountain species is often extraordinary. Populations separated by valleys or peaks evolve independently, creating genetic variants that might appear identical but carry different adaptations. This genetic diversity is a reservoir for future evolution, providing raw material for adaptation to changing conditions. Conservation efforts increasingly recognize that preserving species means preserving not just individuals, but the genetic diversity that allows adaptation and evolution. Microevolution in mountains can be surprisingly rapid. Studies of plants transplanted between elevations show genetic changes within just a few generations. Fish introduced to high-altitude lakes develop different body shapes and behaviors within decades. These rapid evolutionary changes challenge our understanding of evolution as a slow process, showing that under strong selection pressure, organisms can adapt much faster than previously thought. The role of hybridization in mountain evolution is particularly interesting. Where related species meet in mountains, they sometimes produce hybrid offspring that are better adapted to intermediate elevations than either parent species. These hybrid zones can be evolutionary crucibles where new species emerge. The complex topography of mountains, with its many isolated valleys and peaks, creates numerous opportunities for this kind of evolutionary experimentation. Epigenetic adaptations to altitude, changes in gene expression rather than DNA sequence, allow organisms to adjust to mountain conditions within their lifetime. These changes can sometimes be passed to offspring, providing rapid adaptation to environmental challenges. High-altitude human populations show epigenetic changes that improve oxygen processing, changes that can partially persist even in individuals who move to low altitudes. As we delve deeper into our exploration of mountains, let us consider their role in human health and medicine. The thin air of high altitudes has profound effects on human physiology, effects that have been exploited for both athletic training and medical treatment. Athletes train at altitude to stimulate production of red blood cells, improving their oxygen-carrying capacity when they return to sea level. This legal form of blood doping has led to the establishment of high-altitude training centers worldwide, where elite athletes prepare for competition. The study of high-altitude adaptation in human populations has revealed remarkable examples of recent evolution. Tibetan populations have evolved unique adaptations over just a few thousand years, including genes that prevent the blood from becoming too thick at altitude, a problem that affects lowlanders who ascend too quickly. Indian populations have evolved different adaptations, including larger lungs and hearts, showing that there are multiple evolutionary solutions to the challenge of thin air. Mountain plants have been sources of medicine for millennia. The rhodiola plants of high mountains, used in traditional medicine from the Alps to the Himalayas, contain compounds that help the body adapt to stress. Modern research has confirmed many traditional uses, finding that these plants contain unique compounds produced in response to the stress of high-altitude growth. The search for new medicines in mountain plants continues, with researchers racing to document traditional knowledge before it disappears and to discover new compounds before climate change eliminates the plants that produce them. The healing properties attributed to mountain air and water have a basis in science. The negative ions produced by waterfalls and mountain streams have been shown to affect mood and cognitive function. The reduced air pressure at altitude triggers physiological responses that can be therapeutic for certain conditions. Historically, tuberculosis patients were sent to mountain sanatoriums not just for isolation, but because the dry, thin air was believed to aid healing. While antibiotics have replaced altitude as a treatment for tuberculosis, mountain environments continue to be used therapeutically for conditions ranging from asthma to depression. The psychological effects of mountains on human well-being are increasingly recognized by medical science. Studies have shown that time spent in mountain environments reduces stress hormones, lowers blood pressure, and improves mood. The Japanese practice of forest bathing, Shinrin-yoku, often conducted in mountain forests, has measurable effects on immune function and psychological well-being. The combination of physical exercise, natural beauty, and the particular quality of mountain environments seems to provide benefits beyond what can be achieved in urban gyms or parks. Altitude sickness, that constellation of symptoms that affects many who ascend too quickly, has taught us much about human physiology. The headaches, nausea, and fatigue of acute mountain sickness can progress to life-threatening pulmonary or cerebral edema if ignored. The study of these conditions has led to better understanding of how the body regulates fluid balance and responds to hypoxia. Medications developed to prevent altitude sickness have found uses in treating other conditions, and research continues into the genetic factors that make some individuals more susceptible than others. The traditional medicine systems of mountain peoples offer insights that modern medicine is only beginning to appreciate. The use of coca leaves in the Andes to combat altitude effects, long dismissed as mere drug use, is now understood as a sophisticated adaptation that provides not just mild stimulation, but also essential nutrients scarce in high-altitude diets. The traditional Tibetan medicine system, with its complex understanding of how altitude affects different constitutional types, offers perspectives on personalized medicine that align with modern genomic approaches. Mountains pose unique challenges for emergency medicine and rescue. Helicopter rescues at extreme altitudes push the limits of both machines and pilots. The development of portable hyperbaric chambers, essentially pressure bags that simulate descent, has saved countless lives on high mountains. The logistics of medical care in remote mountain areas has driven innovations in telemedicine and portable medical technology that benefit healthcare delivery in other remote regions. The study of hypothermia and frostbite in mountain environments has advanced our understanding of how the body responds to cold and how tissue can be preserved and sometimes recovered after freezing. The seemingly miraculous survival of some individuals after prolonged exposure to extreme cold in mountains has led to the saying among emergency physicians that nobody is dead until they're warm and dead. Recognition that the same cold that threatens life can sometimes preserve it. Let us now turn our attention to the economic importance of mountains throughout history and in the contemporary world. Mountains have always been sources of wealth, though extracting that wealth has often come at tremendous human and environmental cost. The gold rushes that opened up mountain regions from California to the Klondike, from the Andes to the Australian Alps, brought sudden wealth to some and disappointment to many, but invariably transformed the regions where they occurred, bringing roads, towns, and technologies that permanently altered mountain landscapes and communities. The mining of mountains for metals and minerals continues to be economically crucial. The copper mines of the Andes produce much of the world's supply of this essential metal. The rare earth elements needed for modern electronics often come from mountain deposits. The quarrying of marble, granite, and other decorative stones from mountains supplies the global construction industry. Each of these extractive industries presents challenges for balancing economic benefits with environmental protection and the rights of local communities. Water from mountains has immense economic value, though this value is often not reflected in its price. The cities of the world's dry regions depend on mountain water, from Los Angeles drawing from the Sierra Nevada to Delhi depending on Himalayan rivers. The hydroelectric power generated by mountain rivers provides clean energy to millions, with countries like Norway and Bhutan deriving most of their electricity from mountain water. The bottled water industry often sources from mountain springs, marketing purity and mineral content derived from passage through mountain rock. Mountain forests provide timber and non-timber forest products worth billions annually. The sustainable management of these forests presents unique challenges, as steep slopes make both harvesting and regeneration difficult. The value of mountain forests extends beyond wood to include products like mushrooms, medicinal plants, and wild foods that provide income for rural communities. The carbon storage services of mountain forests, increasingly recognized in climate policy, add another dimension to their economic value. Tourism has become one of the most important economic activities in many mountain regions. The ski industry alone generates tens of billions in annual revenue, supporting entire regional economies. Summer mountain tourism, including hiking, climbing, and sightseeing, continues to grow as urban populations seek natural experiences. Cultural tourism to mountain communities, including visits to monasteries, traditional festivals, and indigenous communities, provides income while potentially supporting cultural preservation. The economic multiplier effects of mountain tourism extend far beyond direct spending. Hotels, restaurants, equipment retailers, guide services, and transportation companies all benefit. The brand value of famous mountains like the Matterhorn or Mount Fuji extends to products and services that have no direct connection to the mountains themselves. Switzerland's reputation for quality, partly derived from its mountain image, adds value to Swiss products worldwide. However, the economics of mountain tourism also illustrates the challenges of sustainable development. Popular destinations face over-tourism, with environmental degradation and loss of community character threatening the very assets that attract visitors. The COVID-19 pandemic's disruption of tourism revealed how dependent many mountain communities had become on visitor income, prompting discussions about economic diversification and resilience. Climate change poses particular economic challenges for mountain regions. Ski resorts at lower elevations face shortened seasons and increased costs for artificial snow production. Some have diversified into year-round operations, with mountain biking, hiking, and other summer activities. Others have made massive investments in snowmaking and glacier protection, essentially doubling down on winter sports despite uncertain futures. The economic implications of these decisions will play out over coming decades. The digital economy offers new opportunities for mountain regions. With modern telecommunications, many jobs can be performed from anywhere, and some mountain communities are marketing themselves as remote work destinations, offering quality of life advantages over urban centers. The cool temperatures and clean air of mountain locations make them attractive for data centers, though the environmental implications of bringing industrial-scale computing to mountain environments remain debated. Traditional mountain products are finding new markets through geographical indications and origin labeling. Mountain cheeses, wines from high-altitude vineyards, heritage grains grown on mountain terraces, all command premium prices from consumers seeking authenticity and quality. These value-added approaches to mountain agriculture can make small-scale farming economically viable, supporting landscape maintenance and cultural preservation. The economics of mountain conservation presents complex challenges. The ecosystem services provided by mountains, including water provision, climate regulation, and disaster risk reduction, are worth trillions globally, yet markets rarely reflect these values. Payment for ecosystem services schemes, where downstream water users pay for upstream watershed protection, show promise but remain limited in scale. The tension between conservation and development in mountains reflects broader challenges in valuing nature's contributions to human well-being. The insurance industry is increasingly concerned with mountain-related risks. As extreme weather events become more common, insurers face growing claims from floods, landslides, and other mountain hazards. Some areas are becoming essentially uninsurable, forcing reconsideration of development patterns. The insurance industry's risk assessments and pricing decisions may ultimately be more influential than government policies in determining where and how mountain development occurs. Now let us explore the intricate relationship between mountains and global climate systems. Mountains act as massive climate engines, their influence extending far beyond their immediate vicinity. The Tibetan Plateau, often called the Third Pole, affects weather patterns across Asia and beyond. Its summer heating creates a massive low-pressure system that draws in the monsoon, while its winter cooling contributes to the Siberian high that influences weather across Eurasia. Without this mountain plateau, the climate of half the world would be fundamentally different. The orographic effect of mountains on precipitation creates some of the most dramatic climate contrasts on Earth. The Western Ghats of India intercept monsoon moisture, creating lush forests on their windward slopes, while leaving the Deccan Plateau in rain shadow. The Cascades of North America create a similar pattern, with temperate rainforest on their western slopes and semi-desert to the east. These precipitation patterns determine not just local ecosystems, but entire agricultural systems and patterns of human settlement. Mountains influence atmospheric circulation on scales from local valley breezes to global jet streams. The Rocky Mountains and Andes create standing waves in the atmosphere that influence weather patterns thousands of miles downwind. These planetary waves affect the position of the jet stream, determining whether regions experience cold Arctic air or warm tropical air. The day-to-day weather in New York or London can be influenced by the presence of mountains on the other side of their continents. The albedo effect of mountain snow and ice plays a crucial role in Earth's energy balance. Fresh snow reflects up to 90% of incoming solar radiation, helping to regulate global temperature. As climate warms and snow cover decreases, more solar energy is absorbed, creating a positive feedback loop that accelerates warming. The loss of mountain glaciers and snow cover is thus not just a local concern, but a global one, affecting the entire planet's climate system. Mountains are particularly sensitive to climate change, warming faster than adjacent lowlands in a phenomenon known as elevation-dependent warming. The reasons for this amplified warming are complex, involving changes in snow cover, water vapor, aerosols, and clouds. This rapid warming makes mountains sentinels of climate change, their ecosystems and glaciers providing early warning of changes that will eventually affect the entire planet. The carbon cycle in mountains is complex and not fully understood. Mountain soils, particularly in permafrost regions, store vast amounts of carbon that could be released as climate warms. Mountain forests, while covering relatively small areas, are highly efficient at carbon sequestration due to slow decomposition in cold conditions. Peatlands and mountain valleys store carbon accumulated over millennia, carbon that can be rapidly released if these wetlands dry out or burn. The role of mountains in generating extreme weather events is becoming increasingly apparent. Atmospheric rivers, those narrow bands of moisture that cause extreme precipitation, are often focused and intensified by mountains. The interaction between tropical cyclones and mountain topography can cause catastrophic flooding, as seen when hurricanes encounter the mountains of Central America or the Philippines. As climate change makes extreme weather more common, understanding these mountain weather interactions becomes crucial for disaster preparedness. Cloud forests, those mountain ecosystems perpetually shrouded in mist, play unique roles in regional climate regulation. These forests literally comb water from clouds, with some trees capturing more moisture from fog than from rain. This horizontal precipitation can double the water input to these ecosystems. As climate change lifts cloud bases, these forests are drying out, with cascading effects on water supplies and biodiversity. The dust blown from mountains affects climate in complex ways. Dust from the Sahara, lifted by winds flowing around the Atlas Mountains, fertilizes Amazon rainforests and affects hurricane formation in the Atlantic. Dust from Asian mountains, deposited on Himalayan glaciers, darkens their surface and accelerates melting. This aeolian transport of materials connects mountains to distant ecosystems in ways we are only beginning to understand. The future of mountain climates is uncertain, with models predicting changes that will fundamentally alter these environments. Some mountains may lose their snow cover entirely, becoming dry peaks surrounded by desert. Others may experience increased precipitation, but as rain rather than snow, changing hydrology and hazard patterns. The cascading effects of these changes on water resources, agriculture, and human settlements will reshape civilization in mountain regions and far beyond. As our exploration of mountains nears its close, let us reflect on what these great formations teach us about our planet and ourselves. Mountains are libraries of Earth's history, their rocks and ice preserving records of vanished worlds. They are laboratories of evolution, their varied environments driving the diversification of life. They are engines of climate, their presence shaping the distribution of heat and moisture across the globe. They are sources of resources, from water to minerals, that sustain human civilization. They are places of inspiration, challenging us physically and expanding us spiritually. The silence of mountains, which we spoke of at the beginning of our journey, is not empty but full, pregnant with meaning and possibility. It is the silence of deep time, of processes too slow for human perception but inexorable in their effects. It is the silence of endurance, of rocks that have witnessed the rise and fall of species, cultures, and climates. It is the silence of patience, teaching us that some things cannot be rushed, that the greatest achievements require persistence across generations. Mountains remind us of our place in the larger scheme of existence. Standing on a mountain peak, looking out across ranges that stretch to the horizon, we experience both our insignificance and our connection to something infinitely larger than ourselves. The air we breathe has been breathed by countless organisms before us. The rocks we stand on are made of atoms forged in stars that died before our sun was born. The view we admire has been shaped by forces operating over timescales that dwarf human history. Yet mountains also celebrate human potential. Every mountain climbed represents a triumph of will over adversity. Every mountain community that has thrived in harsh conditions demonstrates human adaptability and ingenuity. Every mountain protected from destructive exploitation shows our capacity for wisdom and restraint. The stories of mountains are also human stories, tales of courage and folly, wisdom and ignorance, cooperation and conflict. The challenges facing mountains in the 21st century are ultimately challenges facing humanity. Climate change, biodiversity loss, unsustainable resource extraction, and cultural homogenization threaten not just mountains, but the entire planet. The solutions we develop for protecting and sustainably managing mountains will be relevant for ecosystems everywhere. The wisdom we gain from mountain peoples about living within natural limits may be essential for our species' long-term survival. As we conclude this journey through the silent power of mountains, we carry with us not just knowledge but inspiration. Mountains teach us that the seemingly solid earth beneath our feet is dynamic, constantly changing, forever in motion. They show us that life can adapt to the most extreme conditions, that beauty can emerge from harshness, that diversity makes ecosystems and cultures resilient. They remind us that some things are sacred not because of what we can take from them, but because of what they give us simply by existing. The future of mountains depends on the choices we make today. Will we continue to see them primarily as resources to be exploited or obstacles to be overcome? Or will we recognize them as essential components of Earth's life support systems, as repositories of biological and cultural diversity, as places where humans can experience something beyond the everyday? The answer to these questions will determine not just the fate of mountains, but the kind of world we leave to future generations. May the stories we have shared tonight inspire you to see mountains with new eyes, to appreciate their complexity and beauty, to understand their importance to all life on Earth. May you find in mountains what so many have found before you: challenge and peace, adventure and contemplation, humility and exaltation. And may you, in your own way, become a guardian of these ancient giants, ensuring that their silent power continues to inspire, sustain, and teach humanity for generations to come. As you drift towards sleep, let your mind wander among peaks and valleys, following rivers from their mountain sources to the sea, tracing the flight of eagles over ridgelines, feeling the slow breathing of the earth itself as it builds and erodes these monuments to time. Rest now in the knowledge that while you sleep, mountains stand sentinel, their presence a constant in our changing world, their silence speaking volumes to those who take the time to listen. Welcome the peaceful dreams that mountains bring, dreams of crystal streams and alpine meadows, of sunrise from summits and starlight on snow. Let the rhythm of your breath match the ancient rhythm of the mountains, that slow cycle of uplift and erosion that has shaped our world. And know that tomorrow, and for millions of tomorrows to come, the mountains will still be there, waiting to share their secrets with those who seek them, offering their gifts of beauty, challenge, and transcendence to all who approach them with respect and wonder. In the quiet of this night, as you rest in the embrace of sleep, the mountains continue their eternal vigil, their peaks catching the first light of dawn while their valleys hold the last shadows of night. They stand as they have stood for millions of years, witnesses to the endless creativity of earth and sky, anchors in the flowing river of time, silent teachers whose lessons we are only beginning to understand. Sleep peacefully now, cradled by the knowledge of mountains, carried by dreams toward your own summit of rest and renewal.